Hello everyone, in this video I'm going to go over reflections. That's going to touch a little bit on chapter 4.7 and mostly chapter 9, section 1, 9.1. Some vocabulary up at the top. A transformation is an operation that maps an original geometric figure, the pre-image, onto a new figure called the image. In other words, if you do something to like a triangle and you move it, that would be a transformation. Now, so the original figure is going to be called the pre-image, and then the new figure is called the image. Okay, so where it says original figure, it should say pre-image right there. A congruent transformation just means you did something to it and it's still congruent. You transformed it somehow, but it's still congruent to the original shape or polygon. So your congruency transformations are reflections, translations, or rotations. Keywords to remember: reflection flip, translation slide, and rotation turn. Okay, so in this video I'm just going to go over reflections, and then the other two are going to come in different videos. Okay. And so to save time, I also have some stuff pre-set up. So you may notice that as I scroll through. Here I'm going to graph the reflection across the line x equals 1. So what I did was I went to 1 on the x-axis and I drew a dotted line. The most common mistake I see is that when people see a line x equals 1, they go to 1 on the y-axis and they draw a line. No, it's going to be a line going straight up and down because it's going to pass through 1 on the x-axis. Jumping ahead, this one y equals -2. See, that's a flat horizontal line going through -2 on the y-axis. So just whatever letter it says it is, if it says x equals, draw the line through the x-axis, wherever the number it is. If it says y equals, draw the line through the y-axis, wherever it says the number is. And that's how you know whether it's a straight up and down line or I guess I should say a vertical line or a horizontal line. Okay. It doesn't matter where the line of reflection is. Excuse me. The easiest way to reflect is to just count. Remember, these are going to be perfect mirror images. So J is one spot to the right. So J prime is going to be one spot to the left. To say something is prime, I just put a little apostrophe by it, and that's what we call the prime. That denotes the image. Okay, so K is 2 spots to the right, so I'm gonna go 2 spots to the left of excuse me, 2 spots to the left of the line, so that'll go right here. K prime. And M is 1 spot to the left, so I'm going to go 1 spot to the right for M prime. And L is 1 to the right, so 1 to the left is L prime. And so when you trace it, it should still look pretty much the same, just kind of like a mirror image. Yeah, let's move on to the next one. Y equals -2. I drew the line through -2 on the y-axis, and now it's gonna fold over. I don't know, like a sandwich or something. So L is 1 spot right above, so I'm gonna go L prime 1 spot right below. M looks like it's at 1, 2, 3 above, so I'm gonna go 1, 2, 3 below, and there's my M prime. J is 1, 2, 3, 4, 5 above, so 1, 2, 3, 4, 5 below J prime. And then K is 1, 2, 3, 4 above, so 1, 2, 3, 4 going in the same direction gets me K prime. So here I have it, and it should look like it folded over. You see J was at the top, now J prime's at the very bottom. Yeah, makes sense. Okay, so let's talk about reflections across the x or y axis, using the x-axis as your line of reflection or using the y-axis as your line of reflection. So if you see something, sorry if there's any background noise going on right now, that's my dog. Yeah, you probably caught that. She's just kind of rolling on the floor, enjoying herself. Alright. Anyway, if something reflects across the x-axis, it's gonna flip horizontally. Okay, so if that happens, you're gonna basically reverse the y-coordinate. So if it's on the positive end, now it's on the negative end. So the first example, I'm gonna reflect points A, B, and C, or the triangle, across the x-axis. All I gotta do is just change the y symbol. So all the x symbols all the x's are the same. Okay. And then so now I go -3 to 0, 0 stays 0, and then -2. I'm gonna go over and I'm gonna graph those points on the graph. So -5, -3. That'll be down here. And then C prime will be right here. And then B, you notice it's on the line of reflection and it didn't move at all, did it? And so you could just reflect it doing just eyeballing it. C was 2 spots above, so I go 2 spots below. A was 3 spots above, I go 3 spots below. You could do it that way too. But that's the rule. If I were to just give you some coordinates and not give you a graph, I'd like for you to know how to do it without graphing it. So before I go to the next one, reflecting across the y-axis, if it goes side to side, that's obviously going to flip the sign on the x, because that's moving it left or right. So this is an x-axis reflection. As you can see, P to P prime, it's moving left to right, Q to Q prime, and so on. So if I were to describe this using coordinate notation, I would describe it like this. I would write my answer like that, where it says symbols, XY, arrow, -XY. That's how I'd say the answer. Okay, so, and just to say what it means, that's a x-axis, or excuse me, a y-axis reflection. Oh, I need to put y-axis first. You get the picture. Didn't space it out very well at all, did I? Whoa, sometimes I have the pin still selected when I'm trying to drag it. Okay, given quadrilateral, A, B, C, okay, all those points. And here's A prime, B prime, C prime, D prime. Describe the transformation using coordinate notation. Okay, so let's look. A is 1, 1. A prime is 1, -1. B is 3, 2. B prime is 3, -2. So I notice the Y symbol is now negative. So if the Y symbol is now negative, that's a reflection in the x-axis. So I'm going to write x-axis reflection, but it says describe it in coordinate notation. So let me just write x-axis reflection. But the coordinate notation is xy, and the pattern was all the y coordinates change signs. So I'll say xy goes to x -y. Alright. Now it says reflect ABC from example 2a in the y-axis. So this was an x-axis reflection, so all the y symbols reverse. So an x-axis reflection, the y-axis reflection, all the x symbols are going to reverse. Oh, I'm talking too much. So I just write -1, -3, and -4. Oh, I left out D over here. And -2. So that's just me looking at all the x coordinates and reversing them. And now I'm going to write down the y coordinates, the exact same number as the original. And then I'm going to graph it to the right. Oh yeah, there was kind of a typo in this graph. I realized it after I made copies that I put the wrong image up, and since this triangle is kind of in the way, I'm just gonna forego graphing it. We got those points. You know what's going on. Okay, the next two examples to go over are reflecting across the line y equals x. Y equals x is the diagonal line that kind of slices it like a sandwich. Slices the coordinate. So just drawing freehand, that's the y equals x line. So for reflecting it diagonally, things go a little bit differently, and it's a little harder to eyeball. So just know that you flip the coordinates. It's the exact same numbers, but they're in the opposite order now. So J is 2, 2, K is 1, 4, L prime, -3, 3, and then M prime is at 0, -4, so that's -4, 0. Okay, and let me just graph it to the right. Okay, and as you can see on my poorly drawn line of reflection, J was on the line of reflection, and now it looks almost like a Pac-Man going down a hill. But yeah, there it is reflected. The only point that didn't move was J because it was on the line of reflection. Now, if I do something across the line y equals -x, my rule for rotating is I'm going to flip the coordinates, but I'm also going to flip both the signs, okay? Not just the x sign, flip both of them. Because if you're changing the sign of the x coordinate and you're plugging it into an equation, then it's going to change the sign of the y coordinate, okay? It just goes back to independent, dependent variable stuff. So y equals -x, again, very poorly drawn line of reflection, going across that line, okay? So I'm going to look at my original coordinates, and they're up here, the J, K, L, M, and they're the same as before. And I'm going to flip the order and change both the signs. So -2, -2. I'm going to go -1, -4. L prime is going to be, so you're flipping it would be -3, 3. So then changing the signs would be +3, -3. Oh, so L prime is in the same spot. And then M prime is going to be at +4, 0. And then I'll just graph it to the right. Okay, so as you can see, L did follow my poorly drawn line of reflection. And so when graphing it, I didn't need to graph a new point. And so when I reflect across the line y equals -x, it ends up looking like that. I don't know. So, like I said, those diagonal line reflections are harder to eyeball. You could eyeball the x equals -1 or reflect across the y-axis, things like that, pretty easily. But the negatives, the y equals x and y equals -x, definitely learn those rules. Flip the coordinates or flip the coordinates and reverse the signs. And that's all you need to know. All right, on to the next section.